Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 4 of lesson number 4, structure of the atom. So if you remember in part 3, we discussed on Rutherford's atomic model, right? So Rutherford's atomic model gave you a brief description on how exactly like protons and electrons come into picture, and like there was some reason why Rutherford had used gold foils and the reason of using alpha rays, right? So I hope every one of you are clear with that concept because it's very important that you know about it. Okay, so now I want each one of you to please revise whatever you have like written in your whatever notes you have taken in your book regarding this structure of the atom, like starting from part 1, because as I tell you in every part that revision is very important for y'all to know the concepts, to know the terms. Okay, so I want you all to please go through it. I hope everyone has started revising whatever you have like taken a note of. I hope everyone is revising properly because like in part 1 I have introduced the lesson very well to y'all because I know the importance of it, right? Because like as this lesson was introduced to y'all earlier, you have a great idea on like Rutherford Bohr's model. They are your friends. Now you will be knowing your friends in detail, like you'll be knowing what exactly work that they were doing and what exactly they have done so far, right? So I just want each one of you to please go through it. Okay, so I hope everyone has done revise, like you all are done revising whatever notes you have taken in your book till now. So now I'm going to show you the slides one by one, and I want each one of you to please go through it. So this is how we have started with this part, atoms and molecules, right? And there are some questions which have been given on the screen. So I want each one of you to please answer them, try to answer them, whatever questions you can see on the screen, try to answer them properly. Okay, I hope everyone is like answering this. So I hope everyone is like able to answer the questions which have been asked on the slide. After this, we discussed about the charged particles in matter, right? So we have like three types of subatomic particles, and these three types of subatomic particles includes protons, electrons, and neutrons. So now we know that electrons have negative charge, right? Protons have positive charge, and neutrons have neutral charge. It means they have no charge, right? So electrons are going to be negatively charged, that is E minus. Protons are going to be positively charged, that is P plus. There will be a positive sign over there. And neutrons are going to have no charge, they are going to be neutral. Okay. Then The mass of an electron is going to be 1 by 2000 times the mass of an hydrogen atom. So the mass of proton is going to be equal to mass of hydrogen atom, and we can take that, consider that as 1 unit. Okay, and the mass of neutron is equal to mass of hydrogen atom, and we can consider that as 1 unit. What can we consider that as? 1 unit. Okay. Sorry. After this, now we, as there was one statement given over here in the last point, if you can see, one of the first indication that atoms are not divisible comes from studying the static electricity and the conditions under which electricity is been conducted by different substances, right? So from where this comes that atom is indivisible, it comes from studying static electricity. So that is why we over here like have performed this activities. You might have studied this before as well, right? So static electricity, we discussed about it, where we have to take comb, we have to rub it on our hairs and then bring it close to the piece of paper, right? And after that we need to bring glass rods and like you need to have silk cloth. So we need to just rub a glass rod with a silk cloth and then bring it near to inflated balloon, and then we need to see what exactly happens over there. Okay, so this is here you can like come to know that you can say static electricity has been produced over here, right? So I want each one of you to please go through it once. I hope everyone is going through this slide. See, here we have like the most important, you can say, points which have been given, and this pointers you should be knowing them already. So make sure you know them very well. Okay. So I hope every one of you are going through it. Here we have information on E. Goldstein as well, because he worked on, you can say, canal rays, and this canal rays he coined them as like, this canal rays were positively charged radiation, which led to the discovery of subatomic particle called as protons. Now we know that we can represent protons as p plus and electrons and e minus, right? So there was some difference between protons and, you can say, electrons. Now protons were equal in magnitude but opposite in sign to that of electron, and the mass of proton was approximately 2000 times as that of electron. So this is something, you can say, very interesting, right? So, and what else we studied about the differentiation between protons and electrons is that mass of electron we can consider that as negligible to -1, and to that of, you can say, proton, the mass of proton we consider it as 1 unit, and we consider that to be +1. Got it, everyone? So I just want each one of you to please go through it once. Like, this is the most important slide according to me, because even you can get an fill in the blanks or one line question answer as E. Goldstein, what exactly he had discussed. So you should be knowing that as well. Okay. After this, we discussed on structure of an atom. So I want each one of you to please go through the structure of atom in detail, where we know that atom is like fundamental unit of, you can say, fundamental unit, atoms and molecules, right? So Dalton's atomic theory plays a very important role when it comes to atom, because Dalton was the one who has suggested that atom was indivisible and indestructible, right? So it led It led to the discovery of two fundamental particles called electrons and protons inside the atom, because of which it led to the failure of the aspect of Dalton's atomic theory. Okay, and here we have information on J.J. Thomson as well, because he was the first person to propose the model for the structure of an atom. Now J.J. Thomson has given us the concept of you can say electrons, right? So it was all because of J.J. Thomson that the electron, protons, and everything became like you can say everything became known to us. Okay. So after this, we discussed on Thomson's model of an atom. Now Thomson's model of an atom is also known as pudding model, Christmas pudding. It has been also called as Christmas pudding. So make sure you know about it. Okay. So I hope every one of you are going through it, and whenever you're writing about this Thomson's model of an atom, make sure you're drawing this positive sphere and the electron. Like drawing and showing where exactly the electrons are present is very important. Okay. So I want each one of you to please go through it once. After this, we discussed on who exactly J.J. Thomson was. So J.J. Thomson, he was a British physicist, and he was born in Chitham Hill, which is again a suburb of Manchester, on 18th of December 1856. Okay, so for his discovery of you can say electrons, which are considered to be a negatively charged ion, he was been awarded the Nobel Prize in Physics in 1906 for his work on the discovery of electrons. Okay, where he has directed the Cavendish lab at Cambridge for 35 years, and seven of his research assistants, they also subsequently won this Nobel Prize. So this is very interesting fact about you can say J.J. Thomson. So he was not only growing by himself, he was not only growing himself, he was even taking along the people who are working with him, because if you are growing, according to him, if he is growing, everyone who is working with him along with him should grow. Okay, so that is the concept. After this, we saw what exactly J.J. Thomson has proposed. So he said that an atom consists of positively charged sphere, and there are certain electrons which have been embedded in those positively charged sphere. Okay, then along with that, he said that the negative and the positive charges, they are equal in they are equal in magnitude. So we can consider that the atom as a whole is electrically neutral because the number of protons and neutrons are equal. So that is why we can say, or we can conclude, that atom as a whole is electrically neutral, right? So although, like Thomson's model explained that atom is electrically neutral, the result of the experiment carried out by other scientists, they could not explain, that could not be explained by this model, as we will see below. So if you can see, he was relating this positively charged protons and electrons as as a model of a cookie. Now there's a cookie and chocolate chips on it. The chocolate chips are going to act as electrons, and the cookie as a whole is going to act as a proton. So that is how he was comparing it. And other thing that he compared it with was, you can say, watermelon. So what happened in watermelon is, the black seeds that we have, he considered those to be electrons, and the red part as the nucleus, which contains protons and neutrons in it. Got it, everyone? So that is how Thomson was trying to propose his work. Okay, so I want each one of you to please go through it properly. You should be knowing what exactly we have studied so far in the lesson. Okay. After this, we discussed on Rutherford's model. So I want each one of you to please go through it once. I hope everyone is going through through the slide, because here we have the information on why exactly Rutherford had used a gold foil, and even the reason of using an alpha particle has been given, right? So the gold foil was been used because he wanted a layer, he wanted a very thin layer as possible. And gold foil, because it was about 1000 atoms thick, so that became one of the reason of selecting this gold foil for his experiment. Secondly, he had used alpha particles as well. Now we know alpha particles are doubly charged helium ions, right? So because this alpha particles, they had mass of 4u, okay, the fast moving alpha particles were like they had some considerable amount of energy. So that also became one of the reason of using this Rutherford's like alpha particle for his experiment. Okay, then it was expected that alpha particles would get deflected by subatomic particles in the gold atom, and because alpha particles, they were much heavier than the proton, he did not expect to see large deflections over there. So that also became one of the reason of using this alpha particle and gold foil for his experiment. Okay, so I hope every one of you have understood this Rutherford's model of an atom and whatever has been given over here, like the reason of using them all. Okay, so I want each one of you to please go through this slide once. You should be knowing the uses of them. Okay, after this we discussed on this like what was the result, like what result Rutherford came up to. So whatever result he got were totally unexpected results because the observations were like most of the fast moving alpha particles, they were passing straight through the gold foil. Okay, there were only few alpha particles which got deflected by the foil by small angles. So what happened is, surprisingly, one out of every 12,000 particles they rebounded. So in the words of Rutherford, this result was almost as incredible as if you fire a 15-inch shell at a piece of tissue paper and it come back and hits you. Got it, everyone? So this was the result that was been obtained, and these results were very unexpected by Rutherford. Okay, so I hope you all have written this and you have even drawn like the scattering of alpha particle by gold foil, how exactly it occurs. Okay. After this, we discussed about E. Rutherford. So he was born in 1871 and he died in 1937. So he was born at Spring Grove on 30th August 1871 and he was known as the father of nuclear physics. Who was he? He was known as father of nuclear physics. So he is famous for his work on radioactivity and the discovery of the nucleus of an atom with the gold foil experiment. So for that he even got the Nobel Prize in chemistry in 1908. Just imagine the work done by him. So he has got Nobel Prize in chemistry. He's known as father of nuclear physics and like see the achievements that he had made, right? So these achievements are very great, and that is how like E. Rutherford was able to come up with this observations. And but like because there were some limitations with his experiment, like because of the drawbacks that he had, where like in the drawback it was like the revolution of the electron in a circular orbit is not expected to be stable. Okay, so any particle, because it is not expected to be stable, so any particle in circular orbit, they will just undergo acceleration. And if there is an acceleration, what will happen? The charged particle, they're going to radiate energy. So when this energy has been radiated, the revolving electron, because they are radiating, they start losing energy, and because of that they fall into the nucleus. So if this were so, the atom becomes highly unstable, and hence the matter will not exist in the form that we know, and that is why they will become like more quite stable. So these are some of the reasons, that is the drawbacks of Rutherford's model, because of which it failed. Like we don't use it, but still the discovery of Rutherford is very, you can say, is been respected, and that is why he was being awarded the Nobel Prize and all as well. Okay, so after that, after discussing the drawback of Rutherford's model of an atom, the further thing that we discussed was like that we need to discuss today is about Bohr's model. Now remember one thing, that like Bohr was like working on the drawbacks of the Rutherford itself, because he knew that there were some issues with you can say with the model, with Rutherford's model. So whatever drawbacks were given by Rutherford's model, Bohr model started like knowing those and started working on those models as well. Okay, so I want each one of you to please go through it once. After this, now like we need to study about Bohr's model of an atom. See, in order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward the following postulates about the model of an atom. So here we have certain postulates because of which like Bohr's model like failed, you can say, not failed, because of the postulates like there was a postulate against Rutherford's model, and as I told you that he started working on those postulates, and that is the drawbacks of Rutherford's, right? So after that, now what are the postulates of Rutherford's model? The first one is only certain special orbits known as discrete orbits of electrons are allowed inside the atom. So according to Rutherford, like all the electrons were not allowed inside the atom. There were only few special orbits which were known as discrete orbit by Rutherford, and only those were allowed, you can say, inside the atom. And while revolving in discrete orbit, while revolving in those special orbit, the electrons do not radiate energy. So these are the two different postulates which were of Rutherford, which was been like given by Bohr's model of atom. Okay, and now Bohr started his research on the same thing because he wanted to know how it can be overcome. So he started studying more about it, you can say. So if you can see the Bohr's model of an atom, that can be represented as like it has four different shells: K shell, M shell, sorry, K shell, L shell, M shell, and N shell. So these are the four different shells which are present according to Bohr's model of an atom. Now if you can see, Rutherford said that there are only some special orbits which we know it as discrete orbits, right? And these discrete orbits are allowing the, you can say, electron to revolve inside the atom, right? And while they are revolving, they are not radiating any amount of energy over there. So these are the postulates, but on those two postulates, Rutherford started working on it, and he came out with certain points that we will be discussing over here on this slide. But before that, we have information on Niels Bohr, what exactly, like who exactly he is and what exactly he has done. So see, Niels Bohr, he was born in the year 1885 and he died in the year 1962. So he was born in Copenhagen on 7th of October 1885, and he was appointed professor of physics at Copenhagen University in 1916. So he was like a Ghana professor at this university in 1916, where he got the Nobel Prize for his works on the structure of atom in 1922. So he was appointed as professor in 1916. In the year 1922, he was awarded a Nobel Prize for whatever work he has done. Okay, so among Professor Bohr, numerous writers numerous writings, three appearing as books are, so like you can say Neil Bohr appears in this book, The Theory of Spectra and Atomic Constitution. Second book is Atomic Theory, and the third book he's been represented at is Description of Nature. Okay, so these are the different books in which Neil Bohr has been known. Okay. So, but before going further, I want you all to please take a note of this two postulates which was given by Bohr's model. Like these are the Rutherford's postulate, but on the basis of this only Bohr's model was functioning, right? So I want you all to please go through it. I hope you all are writing it, and if even if you want, you can draw the, you can say Bohr's model of an atom, the diagram that has been shown. So here we have information on, you can say, Neil Bohr, which we already discussed, but if you want to take any note on it, please take a note of it. So now we have like this orbits or shells are called energy level. What do we call them as? We call them as energy levels. And energy level in an atom, they can be shown in figure 4.3. So if you can see, there are four shells, right? K shell, L shell, M shell, and N shell. If you can see, K shell has N is equal to 1. L shell will have N is equal to 2. Then M shell will have N is equal to 3. And M shell will have N is equal to 3, and N shell will have N is equal to 4. Right? So these are the different shells that we have. Okay, so this is how you should be knowing. There's a nucleus, and around the nucleus we have four different types of shells, which we also call them as energy levels. Okay, so this orbits or shells are represented by the letter K, L, M, N, or the numbers N is equal to 1, 2, 3, 4. We can represent it anyhow. Okay. I hope every one of you are drawing this and writing it. After this, now we have like to study about neutrons, what exactly neutrons are. So see, in 1932, J. Chadwick discovered another subatomic particle which had no charge and a mass nearly equal to that of a proton. So now Chadwick was the one. We know who discovered protons, E. Goldstein. Who discovered electrons? It was J.J. Thomson. Now who had discovered this neutrons? So in the year 1932, neutrons were discovered by J. Chadwick. Okay, and we know neutrons are another subatomic particles which have no charge and the mass is equal to that of the proton, right? So it was eventually named as neutron because it has no charge. Okay, so where is this neutron exactly present? Now we know in the nucleus of an atom, protons and neutrons are present together and electrons, they keep on revolving around the nucleus, right? So neutrons are present in the nucleus of all atoms except hydrogen. So living hydrogen, this neutron will be present in all the atoms, and the exact place where they have been present is the nucleus of all atom. Okay, so in journal, a neutron is represented as small n, and the mass of an atom is therefore given by the sum of the masses of protons and neutrons which are present in the nucleus. Okay, how the mass of an atom has been you can say given by, it has been given by the sum of masses of protons and neutrons present in the nucleus. Okay, so I hope now you know like some information on neutrons which have been given. I hope everyone is taking a note of it. So now we need to discuss that how are electrons distributed in different orbits. So we'll discuss on that and then valency will continue in the next part. Okay. So see, the distribution of electrons into different orbits of an atom was suggested by Bohr and Bury. Who have suggested this? This was suggested by Bohr and Bury, and following rules are followed for writing the number of electrons in different energy levels or shells. Okay, what do we have? We have certain rules for writing this number of electrons in different energy level or shell. So see, the first point that they have given, or the first rule which has been given over here, is the maximum number of electrons present in a shell is given by the formula 2n square. How do we give it? We give this by the formula 2n square. So whatever number, the maximum number of electron which is being present, okay, in a shell, we give that as formula 2n square, where n is the orbit number or the energy number in energy level index. Okay, 1 2 3. This n can be either 1, it can be 2, or it can be 3. It depends. Hence, the maximum number of electrons in different shells will become, like, if suppose we have the first orbit, which we also call it as K shell. Okay, this K shell will be like 2 into 1 because n is equal to 1 in K shell, right? So 1 square will be 1 itself. So 2 into 1 become 2. The second orbit, the n is equal to 2, right? So in that case, the second orbit is called as L shell. So here it will become 2 into 2 square. Now we know 2 square is 4 and 4 into 2 is 8. It means the second orbit can have 8 electrons. Then third orbit will have, like, which is also called as M shell. It has its n is equal to 3, right? So there 3 square will become 3 into 3 is 9. So 2 into 9 becomes 18. So M shell can accommodate 18 electron. Okay. After that, we have the fourth orbit, which we also know it as N shell. Now N shell will have n is equal to 4. So 2 into n, 2n square, right? So n is 4, so 4 square is 16, 16 into 2 is 32. So this is how it is going to, like, move further, and, like, if you have n is equal to 5, so 5 into 5 is 25, 25 into 2 is 50. So the next shell will accommodate 50 electrons. So this is how it goes on, okay? So the maximum number of electron that can be accommodated in the outermost orbit is 8, and the electrons are not accommodated in a given shell unless the inner shells are filled. Now suppose we know that K shell can have 2 electrons, L shell can have 8 electrons, okay, and M shell can have 18 electrons, like that way. So if my L shell is not filled completely, if there are only 6 electrons in it, I cannot move on to the third shell. Got it? Or I cannot, if my third shell is not completed, I cannot move on to the fourth shell. So unless and until the inner shells are not getting filled, I cannot accommodate the further like further shells. Okay, so that is, the shells are filled in a stepwise manner. So atomic structure of first 18 elements, they are been shown schematically in figure 4.4. So this is the atomic structure of the first 18 elements, starting from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon. So these are the first 18 elements, and the atomic structure of these elements have been given. Okay. Depending upon, now you can see there are two shells in some and there are three shell in some. So two shell means they only have K and L shell. Three shells mean they have K, L, M shell. If they have four shell, it means they have K, L, M, N, all the four shells. And we know K shell can have only two electrons. So if you can see, K shell doesn't have more than two electrons in any of the atomic structure. Then L, L can have 8 and M can have 18. So that is the limit that has been given. Okay, apart from that, like no more electrons can enter inside. Got it, everyone? Okay. So now I want you all to write this three rules which have been given on screen, as they are very important for you to know. Okay, so do write about the K shell, L shell, and M shell. So I hope every one of you have written this now. Okay. So now, like, I hope you have understood this about how electrons have been distributed in different orbits. Okay. So today we discussed on Bohr's model of an atom, right? Then we discussed on the neutrons part and how exactly electrons are been distributed in different orbits, where we know that there are four important shells that we have: K shell, L shell, M shell, and N shell. These are the four different shells that we have discussed, right? Now, after this, we are just left with valency. What exactly valency of an electron is. So we'll be like discussing in detail about valency, and the valency of the first 18 elements have been given along with the symbol, atomic number, number of protons it has, number of neutrons, number of electrons, and how they have been distributed in the, you can say, different electrons. Like as we just discussed today, that there are four different shells. We know K shell can have only 2 electrons, L shell can have 8 electrons, M shell can have 18 electrons, and N can have 32, right? So how have we decided that these electrons are present in those shells? Because of the formula that we have, right? What is the formula? 2n squared. So based on number of n, now because L is the first one, so n for K, n is equal to 1. For L, n is equal to 2. For M, n is equal to 3. For n is equal to 4, right? So based on that, we have calculated using the formula 2n square, and that is how we came up with the conclusion that this much electrons can be included under it, right? So we'll be discussing on this valency in detail. After discussing valency, we have like atomic number to discuss in detail, which we will be discussing. Okay, then after this, you can say atomic number in detail, we'll be discussing on mass number in detail, what exactly mass number is. Okay, and once we are done with this mass number, atomic number and mass number, we will discuss on isotopes. Okay, so we'll discuss about isotopes in detail. So isotopes ka, like, we will be having some applications of it, and like there can be some numericals to solve as well. So we'll do that even. Okay, then after discussing the application of isotopes, we'll discuss on isobars, like what exactly isobars in detail. And after that, we will be discussing on, you can say, the summary for the whole lesson structure of an atom, like what exactly we have studied till now. So like summary discussion is very important, because that is what like makes us understand whether we have understood the lesson or not, right? So I'll suggest that you have to be knowing it very well. Okay, so once you go through the summary, you'll understand. If you get each and every point, if you understand the points quickly, and if you don't find that you have any difficulty anywhere in the summary part, it means you are like clear with the lesson as well. Okay, so after this summary, we have like few exercise questions to discuss. So I'm going to show you the questions one by one, and I want each one of you to please go through them properly. You should be able to answer them very easily. Okay, So these are the 19 questions that we will be discussing at the end of the lesson. Okay, so I hope whatever we have discussed so far in this lesson, structure of the atom, every one of you are very much clear with it. Now the rest of the part which has been left, as we know that we are left with valency, atomic number, mass number, isotopes and isobars. These are few of the topics that we are just left with, which I will be continuing in the next part. So I want each one of you to please revise whatever we have studied so far in this lesson till part 4. Okay, so I'll end this part over here, and I'll continue with the rest of the part for this lesson in the next part. Thank you everyone.